Well, here's just a couple of quick questions. Someone asked about polyatomic ions and why they're considered type 1 or type 2 compounds, depending on what they're hooked up with. So polyatomic ions are these ions that show up here. Most of them are, uh, I'm going to say most, I guess you could say all of them. Anyway, what they are is something like NH4, for example, with a positive there. These atoms here are all from the right side of the periodic table, right side of that staircase. Um, and so these atoms here are bonded molecularly, so they're sharing electrons. But when they're sharing electrons, for some reason, they have too many electrons. That would be any of the ones that have a minus charge on them, or they have too few electrons. Those would be the ones with a positive sign. So these atoms are bonded molecularly, they're sharing electrons, but with all the sharing that's happening, somehow there's an electron that's missing or an extra one. Okay, so as a group, they're bonded molecularly, but they have a resultant charge, and so that charge is looking for, in this case, they're looking for an electron to balance that out. Or in the case of, say something like sulfate, it's these atoms are sharing electrons, but there's two extra electrons somewhere, and they want to give those away. Uh, I guess you can say that, give those away to somebody else. Okay? Now, the polyatomic ions, most of them are negative. There's only one, I think, that we have that is a positive, um, has a positive charge. Most of them are negative. That means that they're looking for somebody that's positive. So all of these metals on the left side of the chart, anything with a positive charge, will bond with a negative polyatomic ion. Now, depending on which they take, determines whether they're a type 1 or a type 2 uh, molecule. So say, for instance, I have sulfate and it hooks up with beryllium. So I have beryllium, which is a 2 plus charge, and sulfate, which is a 2 minus. Beryllium only has one type of charge, and so this name, we would name it using the type 1 system. So it would be beryllium sulfate. Now, if I hooked it up, say, with iron, so iron has two options. Since there's two options, that means that this is going to be a type 2 compound. So anything that contains iron is going to be a type 2 compound. So it could be a iron 3 plus or an iron 2 plus sulfate. Okay, and then you can worry about the formulas like balancing. Here the charges are the same, so that compound would just be FeSO4, but you'd have to name it as iron 2 sulfate. This one here, to balance the charges, I need 2 irons and I need 3 sulfates. And this might answer your next question. Um, just to balance the charges. But in this case, since I'm using the 3 plus ion, then the name for this one would be iron 3 sulfate. Now, another question related to that is for something like this, mercury cyanide. Let me just check out mercury to make sure that mercury, uh, sometimes those charges indicated are incorrect. Where's mercury? Oh, right there. So mercury can be a 2 plus or a 1 plus. I'm looking at that pink one. A 2 plus or a 1 plus. Okay, so for this compound, it must be, oops, it must be using the 2 plus ion because cyanide is a 1 minus. If cyanide is a 1 minus, then I need two of these things in order to balance out the charges, right? I need to have a 2 plus here and a 2 minus there, so that's balanced out. So when you write the formula for that. You'll write it as Hg and then Cn, and we put a 2 beside there. But I don't want to say just 2 nitrogens, I want to say 2 cyanides. And so to say that I have 2 cyanides, I need to put this in brackets. Because if I just wrote it HgCN2, that 2, just according to our nomenclature, the 2 only applies to the nitrogen, not to the carbon. So I need to put brackets around that to indicate that I've got 2 cyanides, not just 2 nitrogens. One other question that somebody had questioned my answer key, and I think there's 2 or 3 answers in the answer key where I initially wrote them wrong, but I've left them wrong just to sort of keep people honest. This one's COCl3, so COCl3. So this is cobalt chloride, but I have to check to see whether cobalt's a 1 plus or a 2 plus thing, or a 3 plus in this case. So cobalt is here. So cobalt can play as a 2 plus or a 3 plus. So when I look at it, let me just put both those options out. So it can be a 2 plus, or cobalt can be a 3 plus. And then chlorine is a 1 minus. Chlorine's 1 minus. That's from right down below there. Okay, so if this was the case, then to balance things out, I would need 2 chlorines to balance those 2 positive from the cobalt. So this would be COCl2. But that's not what I have, right? I've got a 3 there, so it's got to be this one. So it looks like I need to have 3 chlorines. That's the 3 minuses here will balance out the 3 plus. So this would be COCl3. To name that one then, I'd have to say, because it's a type 2 ion, I'd have to name which ion charge I'm using. So I'm using the 3 plus, so I'd say this is cobalt 3 chloride. All right, hopefully that helps you out with those questions.